Us off. Good morning, good afternoon, good evening, everybody. Welcome to the October edition of the Year Community Meeting. Today we have Kumar actually presenting two of the topics. He was gracious enough to offer to present on both iree-reduce as well as the new Megabump. Kumar is currently an undergrad student at IIT Hyderabad, as well as a member of the NOD team. And with that, Kumar, off to you.
Yep, I'll just share my screen and let's start. So give me a second. So, are you able to see my screen?
Not yet.
Okay.
Well, yeah, now again.
Okay. So, can you see the slides? It should say test case reduction in iree. Okay, so let's start. So, hello everyone, I'm Kuar, and as Zach was introduced, part of NOD team and undergrad at IIT. And I today will be talking about how I do test case reduction in iree with iree-reduce, and hope to get all of you on board on using it too. So first of all, let's clear up what is test case reduction. So I took this example from John Regar's blog, where this was a bug that was found in GCC once upon a time, and it's really complicated C code, and you can't tell what is happening. So when you run it on GCC, it crashed. And if you really look at it or like start looking through what is happening, it's hard because it's weird code and you can't tell what is going on. So what would you do? You would try to produce a smaller test case. Now, this is a test case that a very experienced developer produced, and he used some tricks that he knew to produce the same crash, but in less lines of code and easier to understand way. So an experienced dev could do this, but what did he exactly do? He simplified some identifiers, changed a function to return void and eliminate an argument, factored some code out of a conditional, and did some interesting refactoring of loop code. And what if we decide to automate this? Instead of having every time an experienced developer to come and do this, what if we have a tool that any person can run and just give us small test cases and file issues like that? So this is what is test case reduction. We take a big test case, use some known strategies to reduce it to a smaller test case, so it's easiest for us developers to fix that issue. Now, what is the need? Why do we need something like this in iree or in more generally MLIR? So I'll take the example of what we have been recently optimizing for, Llama 2, 7 billion parameters and int4. And if sometimes what happens is I've seen some issues on iree GitHub issues, that you compile it, you run it, and there's a segmentation fault. You don't know anything else. Where do you start? What do? You have no idea. It's just a 14 GB file. Who do I give it to other than just filing a reproducer? So this is one example of where I would just be confused. I would just give it to an experienced developer. Hey, Mahesh or someone, can you look over this and find some really small thing like, oh, there's a linal.pack that just blew up the stack allocation. Oh, you should have fixed this. And no, normal person cannot find that unless they have worked with iree so much. So, and other kind of things that happen, bugs on dependencies. Like recently during an LLVM integrate, there was a bug that in risk-free-cost model in upstream LLVM, that it crashed on getting some arithmetic instruction cost. And we do not have experts that know about the patch. They're not working on the same thing as us. So what can we do other than just file a reproducer that, hey, this is some big 1,000 lines or 2,000 lines of MLR code that I have a bug at, and best we can do is just revert it. So what can we do in these cases? Now here's where iree-reduce comes to use. We write some strategies and do automated test case reduction. All we need to run iree-reduce is just a reproducer script, which will take a MLR file. You pass the script will take a MLR file and produce 0 if the same crash is reproduced. That's all we need to run this automated test case reduction. Now, an example I used for reducing the risk-free bug is here. essentially what it does is it compiles and just greps for this get arithmetic reduction cost that the assertion caused to fail, and returns 0 if it can find this assertion thing that outputted, and returns a 0, otherwise it returns a 1. And what I did was, with this, just precompile it to flow, because all the strategies I wrote were for flow level of MLR, and let the reducer go wild on it. And for me, it took the 851 lines of code test case and reduced it to 30 lines of code. And when I put it to LLVM, when I converted it to LLVM, it was around like 50 lines of code. And it was, I think even I could see what was going on wrong, even though I have no idea what could have gone wrong. So this is the power of automatic test case reduction. As a person who has no clue what to do with RISC-V, or who hasn't even done much with LLVM, can just reduce it to a small thing and do things with it. And so this is how to use it. And what does iree-reduce know as of now? It only knows what I taught it. Like for some things I use it, and I taught it four strategies. It replaces a flow.dispatch operation, which is essentially, let's say, a function call. It takes some inputs and returns some output, by a splat, which is that you replace the output of the function call with some constant value. Let's say the flow.dispatch was something like it takes 2 tensors and returns a tensor. And I just say, okay, replace this with a tensor of zeros. So the second strategy it knows is take a flow.dispatch operation and check if it has an operand which matches with shape of the result, and just remove this function call entirely and replace the result with the operand. The third strategy I use is that I taught it is take a lineal.generic operation, which is just a perfectly nested loop, and replace with a lineal fill. Now there's no compute, it's just returning a constant tensor. And another thing I implemented was removing optimization barriers and seeing if something happens. This was just a side effect of the other 3 strategies. I was putting optimization barriers. So this is what iree-reduce knows of now. It knows only at flow level. But let's say you want to teach it something new. And I'll take an example of a strategy I wrote this morning, which I was trying to reduce something in LLVM only, which I don't have a clue about much. So what the strategy essentially did was, it takes these things that look like these scalar SSA values. I have SSA value containing a 0 and a 1, and I add them. And what the strategy I thought of was, hey, I see that the add takes an operand, which is F32, and also returns F32. And if I have a compilation error, not a segment, like not a runtime error, I can just replace the operand with the result. So that's essentially what I do. I replace the out, I just put out is equal to CST, and that's my new SSA value. And now I reduced it by, actually, here you can see I reduced it by 2 lines of code, but it's technically 3, because in SSA you wouldn't have out is equal to CST. You would just go and replace every occurrence of out with CST. So from 3 lines of code, I went to one line of code, and less complexity. It would be easier to look at now and easier to find bugs with. So how did I actually write this? It was actually a really small piece of code that I needed to write, and the rest of things is something that iree-reduce would figure out how to do things. You need to only write 2 things. One is find what you need to remove, and the second part is actually replace it. So let's see how I would write this kind of reduction of taking scalar operands and replacing results with those operands. What I did was walked over the whole IR, find each operation that had a scalar result, and check if I could replace an operand that could do it. And then I have an oracle called chunker, and I ask it, hey, should I keep this feature? If I shouldn't keep this feature, I put it in an array to remove. And that's what essentially the does oracle want me to keep it comment says. If not, chunker should feature be kept. If this feature shouldn't be kept, then put it in a array called scalar map, and I'll later replace this. But if the oracle says that, hey, do not replace it, then I don't do this. And the one part about this oracle is that it expects that each time you run this reduction pass, it basically runs the reduction pass multiple times. You will iterate on operations in the same order. It just expects that, or not operations or on any target. So it's asked that, and if you can push that to the array. And in the replace part of it, you get this array and replace all these targets. You apply your reduction on them. So my reduction here is replace the result with the operand. And then I do some simplification with CSE, symbol DC, and canonicalization. And iree-reduce will go and run delta debugging algorithm with this reduction pass and just try to find a smaller reproducer test case, which still crashes on your reproducer script. And that's it. That's all you need. And what I need from you is more bugs and use iree-reduce to find smaller reproducers on them. And we can probably make this a better tool. Thank you.
I have really appreciated the triaging you've managed to do over the last couple of months with us. It's been great. Thank you.
So I have a question. Okay, a quick question. So this would only catch crashes.
Yeah.
Okay.
You can define crash as anything. So crash is something your reproducer script says it's a crash. I could say my crash is I have, let's say, a iree-compiled version, like some binary that always produces the correct thing. And I know my binary produces sometimes wrong outputs. So I could say my reproducer script is pass both files pass the file to both binaries and check if they match. If they do not match, it's a crash.
Okay, so scenario, you have let's say a ground truth, for example, in a PyTorch model, and it just gives you like a wrong computation in the end. And it has to go through conversion to MOIR, then compilation, execution, and so on. Can I take this tool and somehow like plug in the specifics, like the specific comparison to execution in PyTorch, in order to, I guess, kind of somehow, I don't know how this would work, find the problematic area, because you actually have to, maybe this wouldn't work because you have to actually shard reduce the model, not in MOR, but in PyTorch in this case.
So I don't think that would be possible because PyTorch wouldn't take a MLR file. So in the end, your binary will have to take a reduced MLR file. You could write reduction strategies on Torch dialect, and just if you have a runner for that Torch dialect, you could run that and compare it to that. Other thing you could do is, instead of using PyTorch, you could use the VX dialect. It's and you could compare results with that. But yeah, I don't think you can use PyTorch directly because your input is an MLR file.
So you mentioned that. Sorry.
No, I think, like, to John's point, that's also what I was going to make. Like in this reducing scenario, right? I mean, to find what the numerical differences is. I mean, you should be able to run on the 18 dialect this reduction as well, and compile it with iree all the way down. I mean, this puts a higher bar because now your reduction has to be a valid program still. You can fully end-to-end compile and execute. But combining the iree compile tool and iree run module, you should still be able to do this with numerics. You have to at some point print, and at some point grep, and at some point, if the value doesn't match, so some other tool may need to be involved. But it seems feasible to stitch these together. I mean, if the question is not just which op, then potentially hopefully the location information and the backtraces are sufficient to go back to like the user level, because I think that's the main requirement if you want to actually take it back to which specific PyTorch op is wrong.
But you mentioned it works on the after conversion to flow dialect. At least something I heard something like this.
So that was that I mainly wrote strategies that run on after flow. So the framework is general. It's just I never wrote strategies for that, reduction strategies for that. And the framework, like as I showed, the reduce, scalar operand things is very general. It's just you have to define these are the set of targets I care about. And then you have to define how do you reduce those targets. So you could write this for torch dialect. It would be possible. Yeah.
I mean, perhaps to ask about it, do you have any generic reducers as well? I mean, like the replace with operand example, where it's like, could that just work for every op?
The thing is, I thought about these general reducing strategies. The problem is they like not every operations have weird semantics, and I don't want to mess up their semantics. So for example, for dispatch, I know that there's nothing happening if I just replace the result with the operand. But for some operations, I'm scared that it could. I'm scared that there could be some side effects or just the compilation doesn't expect it. So it's me being conservative. It could work always, just me being conservative, maybe.
Actually, perhaps to that point, you know, and this is probably part of the interesting script as well, right? Where the interestingness test be able to differentiate between this is a crash, this is invalid versus a, you know what case. And so stopping it from further reducing a thing that's already invalid. Is there like different return values that's being used there or something like that?
No, there's only that, does this produce the same crash or not? There's only two things. I'm not sure if we could use like invalid file or doesn't produce crash as, I'm not sure if we can use that information. I do not see it as of now, but yeah, if we do, maybe that could help. Yeah. Oh, one point, like as you said, like about these general reducing strategies of replacing operand with result, I can give you one example of where the semantics mess up. So let's say I take some lineal.generic operation, which takes a tensor.empty, and the result of the generic is returned. And if I return a tensor.empty with this pass, it doesn't make sense. It's undefined. So if I start doing these things in general, we'll run into undefined cases, and I don't know if the reducer producing something undefined is useful. So that's my main problem with writing generic reducing strategies.
I have a question. Okay. So if you produce something that is undefined, shouldn't it then like not be taken by the reducer because it produced a different like bug or different crash? So the reducer in a way will be intelligent and will only select the thing that seems defined because it will produce the same crash, not a different one?
So in an ideal case, yes, but usually you cannot fine grade it that much. Like if you have a segmentation fault, I cannot really differentiate, oh, this was caused by an undefined thing versus like something that actually matters. So I try to keep my things, like I try to write reduction strategies that do not produce undefined things.
Okay, I see. Makes sense.
So I'll talk about this just a sec. So generally you want some sort of undefined behavior detector if undefined behavior is going to cause a problem. When you're looking for crashes, this is usually not a problem. But when you're looking for miscompiles, semantic changes, introducing undefined behavior in the reducer can be a problem. And so, this is when we reduce C or C++, we often run the partially reduced variant under ubsan to check for undefined behavior. When we reduce LLVM IR, we often use alive2 because that is robust with respect to undefined behavior. And, so it's just going to depend on the dialect. But Kunor, you should go ahead and do all sorts of crazy changes and see how it works. You don't have to be cautious about this stuff. If you change the seg fault to a different seg fault, people should just fix that seg fault, and then, and then you can get back to the one you care about. If you have lots and lots of seg faults and you need to distinguish among them, then it's sort of an ill-defined reduction problem, and you don't want to deal with that situation anyway.
Yeah. Okay.
Yeah, this could be a good bug generator. every segfault a new bug, you know.
Reduces are fuzzers, absolutely. They're actually pretty okay fuzzers. Yeah, absolutely, 100%.
Yep.
Awesome. Well, I mean, I think, thanks for the presentation. I think this is, it looks like it has already been very useful in the local debugging you've been doing. And, looking forward to some more interesting reductions there. So if there's no more questions, perhaps we could switch to sort of like the second topic, which is Megabump, which, has a great marketing name attached to it.
Can I at least share the story of that before?
Sounds good.
I literally was sitting on a pile of crappy scripts that I was like, where do I put these? And I created a private repo, and I was just like, Megabump, and then the repo became public, and then that became the thing, and that's the end of my story. So there was no thought to that, and then I just decided for funsies to make the messages that it posts to Discord have a fist bump icon.
So it doesn't stand for the MLR ecosystem generalized aggregate bumping mechanism.
If I was cooler, it should. It does not. Feel free to do whatever you want with it. It was an accidental release of a name typed in anger. Go ahead. I've said my piece and my apology.
Yep. So can I start, or do we have anything before that?
Yes, please.
Okay. So let's talk about integration automation with Megabump. Stella has already given an introduction on what this is, a set of scripts that help you to integration of LLVM to iree. So what does it exactly do? This is just a flow graph of what exactly happens. It helps you. This is what essentially a human would do. Like if I was doing an integrate, I would start an integrate, fetch all the commits, build it, validate it, and see, oh, there are bugs, start fixing them, somehow start bisecting LLVM project, find which commit may be getting me a problem, and asking for help. It's just a lot of work. So what do the scripts exactly do? They help you. You just run a command, it'll start and integrate for you, get you in a fresh state, and then you can run a loop that essentially does fetch one commit that could possibly cause some bugs, build it and validate it, and then keep running this loop. And if you at any point, let's say you have problems with fetching, you could have like some cherry pick problems, some rewards that we were carrying, so you want to fix that, and it'll stop there and ask for help on, maybe it could send a ping on Discord if you want, or you could see it you could see it manually on the script running thing. You could have problems with build, mostly transform dialect, it doesn't match, so it'll ask for help. And while validating, if tests fail, it can ask for help. So it essentially helps you like that, hey, I was building this commit and everything before this was green. After this commit, I have some problem, fix it. So it could be the exact commit or something between two commits. So it keeps you in a bisectable state that you can find what commit exactly messed up, and you can integrate easier. And you don't have to like run it fetch one by one as a human. So it has a bunch of strict scripts, and I improved documentation recently. So I think it should be fairly, like with the help of Stella, obviously. So it should be fairly easy to get started. But I essentially put some docs here directly from the README and some links with it. So you just have to clone the repo, create a directory, and put iree in it, and clone iree in it, and then just get iree directory with some dependencies, Python dependencies, to get it to be able to build and run some tests. And then you just go ahead and start and integrate. And all you have to do is run the scripts, start integrate, and it'll create a new branch. It will create an empty commit which just says start integrate from this, and just puts the starting hash for you. And then the most important script that I currently found is the script's LLVM revision status. It gives you some output like I wrote here. It says that your LLVM project, the submodule we're trying to integrate, is at this local commit, and it diverges from this base, the base commit that it talks about. And anything above this base commit is a local revert or some local patch we are carrying, and it tells you this is the exact thing. And after that, it tells you these are the patches that are upcoming, that are on upstream, but you don't have them, that could affect something in iree. It's just a bunch of patches that could be touching Bazel or something that iree touches. And I want to go with like a live demo here. Also, there are more docs that I added on the README, but I would like to show you the working because I think it's pretty cool. So it's, oh, sorry. I think I need to share a different screen for this. Just share my entire screen. That's easier. Okay. Can you see a terminal yet?
No, not yet. Oh, they're coming.
No?
Yes.
Yes.
Okay. So all you have to do is like clone Megabump, put iree in the create work directory, clone iree into it, and create a Python virtual environment, put some dependencies of iree into it, and get running. So you do scripts, start and integrate, and it will, what it essentially will do is pull iree upstream for you, fetch all the commits from LLVM project, and create a new commit in iree. So if you look at work iree, the first commit will be start LLVM integrate LLVM with the date and whatever branch thing. From here, my favorite script, LLVM revision status. Now it will show you exactly that, hey, you are currently on, that's a lot of commits. You are currently on your submodule LLVM project is diverting at this commit, which is some patch we are carrying locally, which I think we reverted because it wasn't working. Change address of builders to use opaque pointers. And if you go look at there, that it'll show you that anything above this is a local patch we are carrying. And anything below that is LLVM has that, and we will be starting from there. So it just tells you these are all the upcoming patches that that will be fetching in steps. There could be patches in between, let's say affecting something like risk-free code gen, LLVM code gen, that do not directly touch files used by iree, but so we do not step on them. So these are all the steps it'll take, and you can. This essentially lets you know like this is the next commit it will be fetching, and you can see if let's say it was reverted later, so you don't have to fix everything here. The test like it's a known issue, so it gives you an idea of what is going to happen later. And normally a good idea is to go to work iree third-party LLVM project, have a look at that. It told me that everything above this commit is a local patch, so we know. Actually, it said everything above this is a local patch, so we are not carrying any local patches apparently, which is good. Yeah, and if they were, we would have to see if we were carrying any local reverts or any patches that we put early. We could also see them here in status that these are patches that were also reverted upstream, and they will be fixed automatically when it's running the integrate loop. So
hey Kunwar, one thing that I do sometimes when I'm starting an integrate is I'll look at that status dump and see, kind of form a strategy. You know, it's like, is this a brace for torpedoes week or a just let it run? And in this case, I would have looked and seen that while Mehdi was doing 20 different cleanups on Clang Tidy, and I probably would have gone into the status script and like added a regex that said if I see those, just to exclude them in some fashion. That you know, because you're just wasting build time by cranking through NFCs. Except that, you know, usually an NFC and LLVM that's not just a format change is the most likely culprit of a break. So just a note. I usually I usually actively plan a little bit and then tweak the approach.
Yep. Okay. Yeah, I think in as Stella said, in LLVM revision, I think you can specify which paths you're tracking, and I think you can probably modify the code to say do not track some specific paths, or like some grep some commits like clang tidy fixes which maybe which are unlikely to have crashes. So yeah, we could also exclude those. And I'll go the first like manual way of running the loop. So the manual way of running the loop is I take LLVM revision and I say next. What it essentially does is pulls the next commit that we are tracking in as an LLVM revision status, as we saw the list. It'll pull the next commit and put just advance the submodule to that. And then after that, we can do scripts, build and validate. It'll essentially rebuild iree and run some simple tests which are defined in scripts, build and validate. It runs iree test steps and tries to build everything, tests some simple tests to see if we have any simple failures. So, and this is just the fetch, build, validate, and then we go back to fetch. So you could run this loop manually, or you could just do scripts loop.sh, and it'll essentially just start doing like pull one, build, validate, everything goes fine, go to the next one, fetch it, build, validate, and keep on going on this loop. So another thing that helps usually I've seen is that you look at LLVM status, and you can by luck, or sometimes you can be like, I know that anything up till here doesn't really cause any issues. I just know that I read this commit messages and some oracle told me, hey, this will never cause a problem. What you can do is LLVM revision next, and you can put a -- advanced to, and basically put the commit ID here, and it will fetch all commits till there. So you essentially took a big leap instead of a smaller leap. And you see now we are at above that. The next commit will be above the commit that was above the Pressburger commit. And it just helps you run this build, validate, fetch loop kind of thing. And yep. And one thing is that if something crashes, it'll put it in this iree build log. There'll be like a reproduce just what the crashes caused were in case you have just a crash. And you can run this gen iree LLVM error report script. It will look at the iree build crash and just send a webhook notification to Discord. Let's see if, and I sent one. It should be on Discord. I don't have it open, but you should see it if you have it open. And it just looks at the iree build log, sees what the crash is, and sends it to Discord for some ask for help. And that's the scripts that I used. I updated the README so with a lot of things that I understood. So there's setup instructions there. There's instructions of starting an integrate and what can you do with it. There's instructions on running the main integrate loop and what to do on failure. And thanks, Stella, for adding like a lot of instructions on how would you handle like breakages if something breaks. There's specific sections for that, API changes, TensorFlow impacting stuff, upstream bug, and you can look at those. And either of us can improve documentation if needed. Yep, and that's all I had for this.
Yes, so with the tool to skip over commits, so it's a case where the current process, there's no intention to keep it green throughout, but just to help find a green spot.
Yeah.
Basically, I had two goals with this. One was that, without having infinite knowledge, I wanted to take steps that had a high chance of locating, single patches that could be actioned and fixed instead of like going and looking through the haystack, and then also keeping the branch itself bisectable. So, there's actually two levels of bisection that you do on this. One is at the iree commits on that branch, which, will have one commit for every LLVM LLVM advance, and then in some occasions, if you've got like a patch between those that breaks something, then you do have to do a bisect between 2 points on there of the actual submodule. So it's 2 bisect procedures, but you pretty much make sure that there's no API breaks ever between commits on the branch, so that you can navigate, move forward and back, and do all the normal things. Because the pattern that I saw all the time is people are making these big jumps, and they're jumping over 3 API breaks and a backend break and a blah blah blah, and then you spend all your time patching the API break, and then you find the whole thing is busted, and then now you're 6 hours deep in the process and you can't get out. So this reduces the drama. It basically, a lot of times, if I get to the point where I'm like, oh, we're getting into deep water here, this is bad, you just back up a couple steps, land it, call it a day. The next day, start over again. So it lets you always make persistent, durable progress forward, and then you can keep going. And that was the design goal and how I was doing it. The rest was just scripts that grew around that.
Yeah, I think the API breakage one is a good point, because I think that's sort of, without that, you're suddenly dealing with many different things all combined.
So in practice, there's 3 kinds of breaks that happen, right? There's API breaks and single commit breaks that you just farm out. It's like this patch broke something. There's non-affecting breaks that some functionality thing caused a crash in the compiler or something, you fix it. And then there's integration breaks, where if you push the branch periodically, it'll run the full test suite. And so at the end, when you're trying to land it, you look at it and you're like, oh, I'm red on the CI, and you say, okay, I've got 10 points on here that that the full CI ran. You look and you're like, that one was green, that one was red. You bisect between that, it's 10 minutes, you're done. And so that's like, I just found myself doing that process over and over again and just optimize that.
Well, I mean, I like the Discord bot as well. I mean, when's the dashboard coming?
The dashboard is the status. I think Kunwar wanted to make a bot so we could just go to the channel and say, tell me the status.
Well, I mean, I'll be honest, like GitHub notifications being what they are, bot is almost the easiest way to surface any information that anybody will see, so understandable.
Yeah, I think I wanted to play around with the Discord bot API to see what change their API from like command stuff to some slash thing, and I wanted to try it. So what better way to try it other than iree-integrate?
Yeah, I wanted to do that too. I just, as a matter of how to create an automated process, you start by creating a human process, and then learn how to do that, and then you learn, and then it's easy to like extend it, and then you plug ChatGPT into it and just tell it to run our integrates, and we're done.
I mean, I think we need to combine congrat bots and blame bots all together, and then we can have them argue amongst each other who was to blame, and then humans can be involved. Awesome. This is great. Thank you. I think this will be quite nice. And I think we have talked about setting up the integrate rotation. I don't think we're at the spreadsheet part yet, but that's probably next. And then, this will be useful for a lot of folks coming afterwards that need to go through the same process.
It is an evolving process. I mean, I ran the integrate for about 3 months on my own over the last 3 months, without anyone. Largely every integrate I would like move it forward a little bit, and then this last week was the first time I'm like, this is, Kunwar seems like a brave person here. Why don't you give it a shot?
That's awesome.
But then there's also other coordination. You'll get pinged from other projects who want to sync to our commits or something, because because one byproduct of running close to head like this is that that we're often a source of good commits. So the person in charge, ends up being in the out and about a bit.
Yep.
Yeah, I'm wondering if having this kind of commit by commit perspective could help us improve test coverage or build stability upstream, or at least get a sense for, is it getting healthier or worse, and which parts are unhealthy?
Yeah,
So it'd be a good outcome if this doesn't end up needing as much of the powerful tools. The tools look great.
yeah, it definitely improves visibility. Again, API breaks. I'm not going to name names, but I can almost always pick where the API breaks are coming from if I look at a commit log, and that you just deal with them. The testing failures, I found no pattern to it. Having more cheaper smoke tests helps immensely. Because we're basically using the build of Iree test steps as a smoke test that basically says the project is minimally buildable. And then I haven't seen a pattern yet to the madness of actual failures. If you are running close to revert, and I learned this when I was doing integrates on the Google side too, where they run very close to head. You just have to be a little bit knowledgeable that you might be the first person that's consumed this commit, and take a communicate and revert policy and stuff. Be polite, but don't assume that it's gotten a lot of mileage on it. And so there's usually a few LLVM reverts a week that we end up pushing, and that's I haven't seen any pattern to where they come from. It's just like I couldn't make a recommendation of like better testing here.
Okay. Yep.
I don't know, Jacques, you have a lot of experience with this too. Does that match your perspective, or?
Like testing and having engineers be burnt out. Yeah, I agree. That's normally a good way to go.
Yeah.
No, I mean, sorry, I was slightly distracted, but I mean, I think here it is definitely a case where I think the more incremental and the more continuous it can be done, and with farming out to other folks, I think that ends up being the best result. Which of course may be completely unrelated to what we've just discussed, but Mahesh.
I was wondering if some of this can be used to create a post-submit bot on LLVM, so that this automatically just does that.
So LLVM actually has.
Convince your coworkers and your community colleagues to stop fucking breaking the APIs. Otherwise, there is no.
No, I know LLVM already has, but I think it's a question of us setting up a post-submit bot that sends out a blast that this commit broke something.
Yeah, but what I'm getting at is that there's not enough good sequences. People are randomly breaking the APIs enough that that's a non-signal to basically say so and so changed renamed this stupid thing, and everyone has to adapt. Like there's enough of that noise going on that that there's no possibility of post-submit bots.
That's true.
And that is just a cultural thing that doesn't happen very much in LLVM proper. It's still happening in certain parts of MLIR, and I think that like social pressure is important there. That we're running outside of the norms. Sorry, that's my perspective.
Okay. So, well, we have a couple of minutes for questions if anybody has any. We'll have our next meeting set up, I think, like I said, potentially a couple of weeks as well. But if there's any topics, especially from folks in the community that that are curious about, that they want to ask, discuss, now would be a good time.
I just had a thought on that point. When the bump script breaks, we could track stats on which file paths were modified by the patches and just aggregate those. Just if we wanted data on what parts of the code base were affecting things, it seems like a pretty simple way we could collect it.
Yeah, I mean, this is sparse enough. You don't even need, like, I just like remember it. it's, it's not as bad as we're getting at. You know, it's usually quick fixes, you know, or planned things. But the issue is that you can't like have an automated thing that keeps you as an LLVM post submit if your rate of API breakage in your upstream project is like every day or multiple times a day. Just can't do it.
Yeah, I'm not sure. I'm not suggesting that there's anything to do here. Just a signal for a couple of things. API breakage, MLR said that those are easy to fix. You know, just like go fix it up and stuff. The harder ones there have been changes in MLIR that uncover bugs in LLVM. Those are the hardest ones, and there's no testing for that anywhere, which is kind of like we are the ones who are testing that. So
yeah, and I've bisected every one of those after the last 3 months. You know, I'm the one that gives you the here's the commit that broke.
yeah.
Like it's I had more testing in MLIR. You know, more of that is good. Relying less on high frequency experimental changes in tree. You know, all this stuff adds up to a good place. And then just mileage on some things. You know, usually when we reduce something, you've got to like insist that when it gets relanded, it has test coverage. You know, something like that. I don't know. But there's no getting around that expected or unexpected, you're going to be bisecting into the void and finding a random thing. I mean, that RISC-V patch that Kumar posted was a really good example. Like everyone looked at that and is like, oh, RISC-V backend, that's experimental, we don't care. I'm like, but it broke the x86 backend, and you know, only in this situation. And that I had to do a 3-layer bisect to get to that one.
Yeah, I mean, another example just is that there was a MLIR vectorization change that hit an unsupported NVPTX scheduling selection DAG thing, which is still not resolved actually. But it's like, wow, that no one commit is a problem for it. So it's not like this commit broke, so you revert that commit. It's actually that commit is fine, but it's just hitting a bug in LLVM, and then that fixing that is like. For all this work, people in LLVM community are pretty responsive. So they kind of look at that and try to navigate that. But
I think that for those things that break an MLIR, we just have to hold to the line of revert. You know, we are the testing. You know, revert is it doesn't need a high bar of evidence to revert something. If one part of the code base is breaking another part, it doesn't matter if your commit was perfect. The system is still broken. You got to revert.
Yeah, I mean, I think that's also where getting there early helps. I mean, actually, somebody just pinged about something that broke them, which was submitted September 15th. You know, so that's a bit of a long time in between something landing and figuring out it actually broke you, which then complicates things because now folks have stacked things on top of it.
Right, and so like we're usually at most like 3 days from head. We're a little bit behind now because there was something that took some time to triage. But you know, usually first responder, you get there, it's still fixable. You just revert, and it's be polite and revert and be like the whole system is broken. Here's a test case. Can I work on it asynchronously? That sort of thing. Because no one means to do this. It's just, you know, like. If you found it, you know, move the train forward.
Yeah, and I think that the test case one is a good one. I mean, like the amount of, I think people are normally very responsive and happy unless you tell them go download this 34 gig file, then get grumpy. But which, to be fair, this takes time to sometimes get a smoking gun and a nice small one, you know. So, but yeah.
Yeah. You know, look at the statuses. There's a lot of revert relands, you know, because of this, because this was exposing and unexposed the system, and you know, don't be shy. Ask for revert.
I mean, just to actually share some positive news. You know, like I was updating the Haskell bindings over the weekend, and it hasn't been touched since January, and it required 6 lines of changes. So I'm like, that was pretty damn amazing for me. All the tests passed with vector dialect involved and shape dialect, and you know, it's like, wow, you know, it's.
Yeah, we haven't had to do a bump of TorchMLR or stable HLO based on on our depths based on an API break in I think 2 or 3 months. You know, it's that part of the stack is getting better. Gunwar, thanks for test driving.
Yeah.
Thank you for building it.
Okay.
One other meta feature of this is because it's just Git. If anyone drives and gets overwhelmed, you know, or gets in deep water, you just hand it off. It's just a branch on the server. You know, there's like I tried to put this process together so that, you know, normal times can be normal and low drama. And then when it requires heroics, you know, you call in someone, call in the fire department and just take over the branch. There's no like no heroes, no driving this to the bitter end, all that stuff.
All right. Thanks very much for joining. Thanks for the great presentation. And you know, please feel free if folks have any questions. There's the form to fill in for the community meeting for topics, and then we'll see. Well, soon to actually talk about the metal howl. You know, so I'm looking quite forward to that. All right. Have a great day, everybody.